Hello everyone, so today we are going to talk about how to send log analytic error reports by filtering data from an entire resource group. And what we pretend to do is to create a logic app that sends reports through log analytics using an Azure function to dynamically retrieve the data. And to do this, first we need to understand a few things. First, what is the log analytics workspace? The Log Analytics workspace in the Azure portal is a centralized place where you can collect, store and analyze data from various sources, such as Azure resources, applications and servers. Think of it as a tool that helps you keep track of everything that's happening across your Azure environment. It allows you to perform advanced analytics and visualize data in real time to help you identify and troubleshoot issues quickly. You can also use it to create custom queries, alerts, set up automation tasks, and integrate with other Azure services to get even more insights into your data. Overall, the Log Analytics workspace is a powerful tool that helps you stay on top of your Azure environment and ensure that everything is running smoothly. So as explained, we can create custom queries to retrieve data from Azure resources, for example, logic apps. And how does that work? But first, to get there, you need to create a Log Analytics workspace. So search for Log Analytics in the search bar in the Azure portal and click on it. Next, click on Create. After this, you will need to populate some fields with information you find more appropriate for your scenario, like your subscription, the name of your Log Analytics workspace, your resource group, and the region. After this, click on Review and Create, and finally click Create. Next, this is what you should see, your Log Analytics workspace overview page. Now, if you click on Logs, it will open a panel that works via queries, and some of them are already built-in queries. But for the sake of this POC, we are going to use our own queries, so you can close this window. Closing the previous window will give you access to a panel where you can write your own queries, and they work based on a scope. For example, you can apply a query into a resource group as you can apply it into a specific logic app. You also have a time range you can apply to query events that happened in the time span you have defined. But about queries on Azure Log Analytics, how do they work and how to write them? In Log Analytics on the Azure portal, queries are used to search and analyze the data that has been collected in the Log Analytics workspace. Think of queries as a way to ask questions about your data, such as how many times did this event occurred, or what is the average response time for this API. Once you write a query, the Log Analytics workspace will return the results in a table format, which you can then use to gain insights and make data-driven decisions. To write a query in the Log Analytics on the Azure portal, we will need to use a query language called Custom Query Language (KQL). And what is Custom Query Language? Custom Query Language is a language used in the Azure Data Explorer, Azure Monitor, and Log Analytics for querying large datasets. KQL is a simple yet powerful language that allows you to search, analyze, and visualize data in a flexible way. KQL has a SQL-like syntax, but also supports many features that are specific to Azure services, such as functions for querying JSON data, time series data, and hierarchical data. Some of the key features of KQL include support for querying structured, semi-structured, and unstructured data, built-in functions for working with dates, strings, arrays, and other data types, support for aggregations, joins, and subqueries, ability to query data in real time, integration with Azure services for data collection, storage, and visualization, and KQL is a powerful tool that can help you with gain insights and make data-driven decisions, especially when dealing with large datasets in Azure. Here is an example and part of the query we are going to use in this POC. This query is used to find and retrieve information about failed logic app workflows from Azure diagnostic logs. It looks for specific events related to logic apps and filters them based on the workflow status being marked as failed and having a non-empty error message. The query then selects and displays two pieces of information for each failed workflow, the logic app name and the error message associated with the failure. This helps identifying which logic app workflows encountered issues and provide details about the specific errors that encountered. The project operator is used to select specific columns to include in the results. In this case, the query will return the workflow name and the message for each event. The pipe operator connects the different parts of the query together. So now you have an idea of how query works, and like we said earlier, what we pretend to do is to create a logic app that sends reports through log analytics using an Azure function to dynamically retrieve the data. You might not understand why the Azure function, but as we advance, it will make more sense. So to make this possible, we need to create a connection between the resource we want to collect data from and the Azure Log Analytics. To do so, let's create a logic app. And in doing so, do not forget to use the same resource group and region you have your Azure Log Analytics stored. Give the logic app a name that makes sense to you and to your coworkers, and as you already know, start using proper names from day one. Also, it is important to know that you will only be able to query and interact with Log Analytics data if you have resources pointing to that Log Analytics workspace. So for future references, when creating a logic app consumption, you are able to choose the option Enable Log Analytics. Click Yes and choose the Log Analytics you have created. This way, that logic app will send data to that Log Analytics workspace that can later be queried. So now you can start your logic app using the recurrence trigger, and you can choose the interval as 1 and the frequency as day. Next, choose the connector Azure Monitor Logs and the action Run Query and List Results. Next you will have some fields to populate, like your subscription, the resource group, the resource type, the resource name, the query, and the time range. It is on the query that you will type the query you want to be executed. Of course, we can test our query first in our Log Analytics workspace to check if everything runs smoothly as we intended. In this case, we get the results we expected. This query helps you analyze and summarize failed logic app workflows by grouping them based on their logic app name, error message, date, and time. In simpler terms, this query helps you understand and track the number of times different logic apps have encountered failures, along the corresponding error messages, dates, and times. It summarizes this information to give you an overview of the frequency and the patterns of failed workflows. Going back to our logic app, we can then use the same query in the query parameter inside the connector. Also, use the same time range to get the same results, but of course, you can use different time ranges according to your business needs. If you save and run your logic app now, the query will be executed. Here is a snippet of the outputs. You can verify that we have the same information we got in the Log Analytics workspace. The logic app name, the message, the date, the time the event occurred, and how many times it occurred. But instead of this information being presented as a table, like in the Log Analytics workspace, it is presented in JSON format. Now we have two options. Option 1. Send this report as an HTML table, as it is, using a data operation, create HTML table, and then send an email with this information, being that the email will look like this. A bit outdated, for our taste. We can send a more refined report that looks like this, being that this is the option 2. In here, we have a report that is more appealing to the eyes and easier to read. And to achieve this, what we have done was to use an already HTML-based document and an Azure function to retrieve the rows. So this means that we need an Azure function to inject the HTML rows into the code we already had. So we created an Azure function with that purpose. And this is how we have done it. First, open Visual Studio 2022 and create a new project, and choose the project to be an Azure function. Next, give the name you find more appropriate to your new Azure function, and choose the location of your project. And you can check the box Place Solution and Project in the same directory. Next, for this POC, we selected the trigger to be an HTTP trigger, and the authorization level as anonymous. Next, erase the pre-built function that comes by default in the Visual Studio, and here is the code we use. And what does this other function do? This other function accepts an HTTP post request and returns an HTML table. The function takes the request body, which is expected to be in JSON format, and extracts an array of objects from the property body.value. Each object in the array represents a row of data for the HTML table and has 5 properties: logic app name, message, date, time, and count. The function then iterates over each object in the array and builds an HTML table row for it. For each property in the object, the function appends a new cell to the HTML table row with the corresponding value. Finally, the function returns an HTTP response with a body that contains the completed HTML table. The response content type is set to text HTML, indicating that the response is an HTML document. Next, publish the Azure function. Publish it by going into the Solution Explorer and right mouse click on the project and then click Publish. Next, choose Azure. Next, choose Azure Function App Windows if that is the platform you are working on. And next, validate your credentials. Choose your appropriate resource group and click and create new. Next, a window will pop up, and you need to populate the fields with the appropriate information based on the solution you are creating. Next, click on Create, and finally you can click on Publish and let the deployment occur. In Azure Portal, if you check your function app, you will see that you have the Azure function we just created there. And what you need to know is that in our logic app, we will need to call our Azure function. And to do that, you will need the URL from the Azure function we created. So you can copy the URL as you can see in the image we present. So going back to our logic app, add a new step, this time an HTTP call. And what your logic app should look like until here is like this. Next, configure the HTTP action. Set the method to post and the URI, paste the URL we just copied from the Azure function. On the headers, set the key to content type and the value to application/JSON, since indeed it is a JSON that we are sending to our Azure function. Next, on the body, dynamically choose the outputs from the previous action. This will ensure that you are sending the Azure function the queried outputs. Next, add a variable with the HTML template we discussed before and dynamically add the body result from the HTTP call to that variable. You must put it in the right place so the HTML will be formatted correctly. Next, add a condition. This condition will check if the body is equal to null. If that is true, then the condition does nothing. This is useful in the cases where there is no data to present and you don't want to spam your teammates with emails without content. But in the case the body is not null, meaning there is data to present on the body, an email shall be sent. Next, configure the Outlook connection. On the body of the email, add the variable containing the HTML template and the Azure function call result, and add a subject and an email. In the end, your logic app should look like this, and your reports should look like this. In a business perspective, if you have a great amount of data being processed in your logic apps, you can now receive error reports if something fails, and you can choose the frequency in which these reports are sent. Remember that, for example, if you set the recurrence as daily and the query also is looking for events that have occurred in the last 24 hours, you might not have an email to present, since the condition prevents it to send the email if the body is null. But this also means there are no flaws in your logic apps, which is always nice. Hope you have enjoyed this POC as much as we did, and we will see you in the next one.